Well, hello and welcome YouTube, Mr. Robinson's Q&A Power Hour. This is going to be probably a pretty short one, probably less than an hour here. I'm taking my students' questions, and this is a Q&A video of sorts from both Integrated Math 1 and 2. I actually have one Integrated Math 2 question that's asked, and I'm kind of surprised by that. We're working on factoring quadratic expressions, and I feel like people generally have a lot of different questions on things that come in, but only one so far, and I hope that that one will just be enough for them. And for everyone else who's watching this video here. So I have one of those questions, like 9 or 10 Math 1 questions, and I haven't looked at any of them. I just kind of put them in and said, all right, here we go, let's get started. I like that spontaneity of not knowing what I'm going to run into first, and if they stump me, I guess they stump me. But the point's not them asking me questions for me to, do. It's so they can make better sense of the things that they're doing. So the kinds of questions that they're asking, Integrated Math 2, like I said, is doing a lot of factoring quadratic expressions, even solving some using factoring and the zero product property. My Math 1 classes are graphing and finding equations of linear functions and linear equations, slope-intercept form, Pointslope form, not really graphing out a standard form, but they're going to use standard form to sometimes convert to slope-intercept form and do that. So a lot of things with graphing or finding equations based on a graph or information. Now, for my Integrated Math 1 crew, I do want you to know right now that I did make kind of an extra longer video on the IXL bits that you're going to be working on as well. And I don't know what kinds of questions you're going to have here, but I'll let you know if it's also answered in those. Like I'm saying, if you want to get a lot more exposure, you can get a lot more practice problems there. That's totally fine. I'll still help you a little bit here, but just letting you know that. Questions will be posted in the description section down below with timestamps, and questions are going to be asked and answered in the order that they were received. Okay, so I'm just going to go ahead and get started right now, and let's power through this thing in less than an hour. I think we'll be able to do it. So I just have the one Integrated Math 2 question right here to get us started, and that question right here asks us, how do we know whether it will be plus or minus for the quadratic functions? And my guess, well, I don't know if you're referring to the ones, because we've factored, I'm guessing you're talking about factoring quadratics, but I don't know if you're talking about when it's just x squared plus bx plus c, or whether it's ax squared plus bx plus c. Let me find something. I kind of wish I saw this question beforehand. Let me find something that I made that I'm going to give to you guys here. Let me get that file up. Give me 1 second. It's a table thing. I'm going to first talk about x squared plus bx plus c. I don't know if that's the part you're asking about, but I'll give an example with it as well and say what that's about. And then I'll find another factorable, bigger quadratic example to see, because you might be talking about some other thing we're talking about. I'm prepared to answer it one way or the other for you. Okay, so let's see. I got this going up here. Okay, so I'm going to show you guys this table here, and I'll make sense of what this table means. I might have to shrink it a little bit as well. So right here, you're looking at x squared plus bx plus c. When you have a quadratic trinomial with a 1x squared here, and you have some linear term, linear coefficient that's non-zero, and some non-zero constant term, if you see the signs of them, you'll be able to determine how your factors signs will be represented. And it works like this. You kind of arrow yourself in and say, if you're looking at a positive product and a positive sum, then we're looking at that there. But if you're looking at a positive product and a negative sum, then you're looking at here. Both factors will be negative. Negative product, positive sum is right here. And then negative product, negative sum is right here. Okay. So what does this have to do with? This has to do with when we are taking, and I'll write an example right here. When we're taking, I might have to shrink this, some sort of like, we're factoring a quadratic trinomial, and we're factoring, let's say, x squared minus 7x, what'll work, minus 18, something like that. Well, you want to list your factors of 18. Okay, you want to list your factors of 18, and you got to figure out what two numbers multiply to make negative 18 and add to make negative 7. It can be a combination of something using the numbers 18 and 1, 9 and 2, or 6 and 3. Now, in order to do this thing right, you don't want to be doing 18 plus 1, 9 plus 2, 6 plus 3, 18 minus 1, 9 minus 2, 6 minus 3, negative 18 plus 1, negative 9 plus 2, negative 6 plus 3, and negative 18 minus 1, negative 9 minus 2, negative 6 minus 3. I'm changing all the signs of these positives and negatives for both pairs of things to find out which ones add to negative 7. I can cut that into a quarter of that time by referring to the idea behind this table. I have a negative product, a negative 18, and I have a negative sum of negative 7. Therefore, I know that in my list, my larger number will be negative and my smaller number will be positive. What I mean by that is I can take this negative 18, negative 9, negative 6, add it with a positive 1, positive 2, and positive 3, and figure out which one gives me negative 7. Negative 18 plus 1 is negative 17. No. Negative 9 plus 2 is negative 7. Yes, it's that one. So my answer to the question, what two numbers multiply to make negative 18 and add to make negative 7, are negative 9 and positive 2. So instead of checking something like negative 9 minus 2, or you know what I mean, I'm saving the time from being able to do those other things by creating my list of my positive factors of 18, and then I'm giving them the signs that they deserve based on what's given to really whittle down my list a lot faster than I would otherwise need to. So anyway, that's negative 9 and positive 2. That would factor into x minus 9 and x plus 2. That's just one example. If you have another one where you have a positive, positive product here and a negative sum that I'm looking at, what is that? Positive product, negative sum that I'm looking at up here. Both factors are negative. That's not factorable, by the way, minus 7x plus 18. But anyway, that's the end kind of look to that thing. And if that's the answer to your question, then refer to this table. I'll be providing you a picture, an image of this thing right here online, and you can kind of refer to it here as well. It becomes common sense, though. It's something I say out loud. I never given you this table until now. So before that, I was always saying it out loud in a common sense fashion, but you can refer to this in the same way until it makes sense to you. Bottom line is you do want to whittle down your time. If you are, however, referring to when we talked about ax squared plus bx plus c, and I don't have an example off the top of my head. In fact, I'd rather give one that I don't know the answer to already. So I'm going to Google search one. But if you're talking about factoring ax squared plus bx plus c, I know that we've been talking about when we factor this stuff down here, whether it's not going to be the same table, because now with an a value, it manipulates your outside inside when it comes to distributing. And it's not always certain. It is certain if b and c are both positive, or if c is positive in general. It is certain what it is, and I'll show you what I mean by that. So I'm going to run through a couple examples. I won't talk too much about the whole factoring goals. You asked about the signs, so I'm going to do some of the factoring goals a lot faster on this stage here. But I'm going to do a Google search. Let me pop up Google. And in Google here, let's find a worksheet or something. Factoring quadratic expressions worksheet. I don't want to do the CUDA one I did before. I don't want to use that. That's something you guys have. So let's see what this has. Oh, I want some ax squareds, by the way. Hang on. Ax squared. Let's see if this ax squared plus bx plus c. Let's see if this does anything for me. Because I want to make sure they're the big ones. These don't look like the big ones here. Oh, there's them. All right, see some of these right here. Don't worry if they're not x's and such. We're going to make sure. Hopefully these are all factorable. I'm going to choose a couple of these here. I'm going to do 2a squared. A lot of these are 2's. Here we go. So let's look at 2a squared. I can call them x's, if that's okay, because otherwise you'll confuse it with an a. Where's my browser? Let's look at 2a squared plus 9, or 2x squared plus 9x plus 10. I'm not setting it equal to 0 for now. I think you're just asking about factoring. You didn't mention one way or the other, but that's my guess. Now here's the thing. If you have a positive product and a positive sum, that will be the same kind of thing as the table. I know that if this thing's factorable, by the way, no common factors here. I know that if this is factorable, the only way to get positive product and positive sum is by a plus and a plus. In that when the 2x squared is built by 2x and x, again, I'm not going to get deep into that. You asked about the signs. And then plus and plus is the only way I can get plus here and plus here. It does change when you have a negative product. We'll get into that one last. But right here, 2x plus and plus, I can choose factors of 10, such as 10 and 1, 1 and 10, 5 and 2, or 2 and 5, like that. Figure out which one goes here. I can try 10 and 1. I know this automatically won't work because if this has a common factor of 2, that I should have been able to factor out earlier, so I'm not even going to test it. I can try this. 2 times 10 is 20. Not even a chance. So it's got to be something with 5, 1, or 5, 2, or 2 and 5. It can't be 2 and 5 for the same reason. If I can factor out a 2 from there, and I couldn't before, that's not going to work. So the only chance is 5 and 2. 2 times 2 is 4. 5 times 1 is 5. 4 plus 5 equals 9. And there's the answer. We got 9 and 10. I know you're not asking about the factoring, but I knew that my final answer was going to be a plus and plus with this. Definitely can't be a plus and minus because a positive times a negative is a negative. Could have it been a minus and minus because a negative times negative is a positive? It couldn't have been, but the only thing that would have changed is this would have been a minus 9x. So if this was a minus 5 and a minus 2, so I'm going to save myself from doing one of these later, for a minus 5 and minus 2, only thing that would have changed would have been negative 4 minus 5 is negative 9. So this would have been a minus 9x there. So even if you put a plus plus to begin with a positive product, even if the sum was negative, just see if you get the opposite sign. If I got a positive 9, I know that minus minus will give me negative 9. I wouldn't do it that way. I'd know for sure to put in what to put in there. Those ones are pretty easy when the product is positive. Either they're both plus plus, if this is positive, like that, or they're both minus minus if the sum is negative. Kind of the same as the x squared plus bx plus c. If you can't find something within there, then that means it also wasn't factorable. Now, it gets harder when you get a minus product when it comes to understanding this, and I think this is where most people have their questions on it. I'm sure your question is the same as others. And let me find one in this. I don't see one in this list. So let me find another list of some that would have them. Do these have minuses? Great, we have some. Let me get, are there bigger ones? Not really. All right, 2c squared plus 7c minus 4. So I'll change that to 2x squared plus 7x minus 4. All right, let's go ahead and factor that guy. Again, I'm not solving, I'm just factoring for you. Now, once again, if this is factorable, that means I'll definitely have a 2x and an x. The difference here now, though, is that I have a negative 4, which is a product of a positive number and a negative number. Now, it doesn't hurt me entirely to put a plus here right now and a minus here right now. Will I know if that's correct? I'm not certain yet. I'm not certain yet. Unlike the table thing before, we know that a negative number plus a larger number plus a smaller positive is going to be negative, and we know a larger number plus a smaller negative is going to be positive. The problem is, though, one of our numbers will be multiplied by 2. One of the numbers gets doubled. Even if a smaller number gets doubled, see, if this were 3 and 5, this has nothing to do with our answer. If this was 3 and 5, 3 might be less than 5, but 2 times 3, when we FOIL here, 2 times 3, that's negative 6. Suddenly that became more than 5 times 1. Suddenly that 3 isn't smaller than a 5 anymore because of how it gets affected by being multiplied by 2. That's why I can't use that particular talk in the table from before. Anyway, 5 and 3 have nothing to do with 4, right? 4, factors of 4 are either 2 and 2, which you should know this won't work based on what I said before, or 4 and 1, which that shouldn't work, or 1 and 4. Here's how I know that 2 and 2 won't work and how I know that 4 and 1 won't work. Because 2 and 2 would mean I could factor a 2 out of here, and if I couldn't factor a 2 out of here, that won't work. Same thing with a 4. If a 4 was here, that means I could factor a 2 out of these. I can't if I couldn't here. So the only chance is 1 and 4. I already know that that's going to have to be the answer, otherwise it's not factorable. Again, you're not asking about that, but I'll talk about some other stuff with this. This still might be the wrong answer. 2 times negative 4 is negative 8. 1 times 1 is 1. Negative 8 plus 1 is negative 7. Oh shoot, I wanted a positive 7. Well, all that needs to change is the signs inside here. This plus 1 should be a minus 1, and that minus 4 should be a plus 4. Now I get 2 times 4, which is positive 8, negative 1 times 1, which is negative 1, and positive 8 minus 1 is positive 7. Suddenly I got the positive 7 that I wanted. So from the onset, even I, Mr. Robinson here, wouldn't have known whether it was plus, minus, or minus, plus, because I don't know what numbers are supposed to go in there yet. Depends on where the placement of the 2 is and all the other things. Clearly the 2, 2, I mean, you weren't asking about this, but clearly 2, 2, 4, 1 wouldn't have worked. My only chance was 1, 4, and thankfully that one worked, so it was factorable. Yay, yay, yay. That being said, all I knew is that it would be a plus and minus. I didn't know which place the plus and minus would go, but I knew it needed to multiply to make a negative number. So I need a positive times a negative to do that. So to answer your question one more time, or to finally nail it in, to go to what you're asking me here is, how do we know whether it will be plus or minus for the quadratic functions? I'm guessing you're talking about these. They'll both be pluses if your product is positive and your sum is positive. They'll both be minuses if your product is positive and your sum is negative. If your product is negative, I would just put a plus and minus in. I would play with which numbers give me either this number or the opposite of it. If it gives me this exact number, keep the signs as they are. If it's the opposite, change the signs. I'll do one more example for you just to nail it in, but that was my recap bit. And remember, I haven't seen these problems before, and these ones are kind of basic-ish though. I'd rather get some larger numbers, honestly. Let me try and find another worksheet here, just to do one more with you. Sorry, you can't see what I'm... Let me go Google browsing. This might change my power hour into an actual hour, because this one IM2 question. I'm spending time on the IM2 question because there were no other IM2 questions asked, and I'm not certain whether or not people are going to have questions for me down the line. Okay, here are some good ones right here. No, those are factors. I can factor out those numbers here. Those aren't any good. Oh, this is back to CUDA. Wait, actually, let me see what's in here. No, those aren't really well, sort of. I mean, this one goes beyond what you would be asked to do. Let's look at this number 18 here. This one's going to be fun for me. Shoot, I know the answer already in my head. Let's do number 16. I don't know the answer to that in my head already. I want to pretend like... See, sometimes, like when your brain, like stop brain. Don't think about what you're thinking about right now. Even though it might try to. But I want to do this one here because it has a negative product. So one more time with a problem like this here, and back to your question. Oh, hang on. Back to your question right here. How do we know whether it be positive or negative? Negative product. Now, first of all, if it's factorable, that means it's going to look like this. We know there will be an x and x. I don't know whether this will be 3 times 3 or 9 times 1. This 56 here, negative 56. Negative product means I'll have a positive somewhere and a negative somewhere. I don't know which order it goes in yet. The order will not matter if this is a 3 and 3. Because whether I put, 8 and 7, I don't know what the answer is yet, but whether I put like an 8 and 7 here, actually this might be the answer. Shoot, I hate doing that. Whether or not this will be an 8 and 7 here or a 7 and 8 here. Oh, you know what? Yeah, the sign will matter. I'd take it back. The sign will matter there. It's 3 and 3. Placement of 8 and 7 won't matter. The plus or minus will. Okay, well, I did put 3 and 3 as a start. I was trying numbers that, the closer your number is to 0, because 7, overall 7 isn't that large when you compare numbers like 56 and stuff. When your numbers are closer to 0, I'm more compelled to find products that are closer to each other when it comes to your number, instead of trying 9 and 1. Instead of 56, instead of trying something like 56 and 1, 28 and 2, 14 and 4, I'm more inclined to choose numbers that are closer together than not, because I need to get to a number close to 0 when it comes to a subtraction, a difference. So I'll try 8 and 7, like I said I'd try. I forget if I tried 8 and 7, 7 and 8. But here's 21 minus 24. Okay, well, actually good. That one's not the answer. So 21 minus 24, that's negative 3. Now, my point to what I was stating here before is there's no reason for me to try ever negative 8 and positive 7, because that'll become... Hang on, was I just doing that? I'm sorry, this was negative 21. I'm sorry. This was negative 21 plus 24. Now, when I do this, I'll be getting 21 minus 24. It's positive 3. And this will be a negative 3. So if I switch the signs, I'm just going to get the opposite sign of my answer. So, anyway, there's no reason to test that. So I might as well just leave it as plus, minus, start testing some numbers and see what goes on. Now, in this case, it will not be worth it for me to switch the 8 and 7 for the reason I stated before. But plus, minus here. Let's try other things with 3. Let's try... This won't work, I know already, but let's try 14 and 4. Reason I know this won't work is because this will be an even plus an even, which would equal an even. This is an odd. But anyway, negative 12 plus 42 is 30. So again, switching the signs, I'd get negative 30. So I know that's not going to work. And it'll get a little outlandish to try the 56 stuff. So unless there are other products of 56, let me check them. 56 divided by 1 is 56, divided by 2 is 28, divided by 3 does not work, divided by 4 is 14, divided by 5 does not work, divided by 6 does not work, divided by 7 is 8. So these are my only product things I should try. I don't think 3 and 3 will work inside here, so I'm kind of glad I didn't land on the answer the first time. And again, I know I'm teaching people how to factor within your question. I think I answered your question already, I hope. But I'm just continuing on. So, okay, if it's factorable, that means it's going to have to be some sort of 9x and 1x. So now I'm going to play with things like, I don't think in this case 8 and 7 will work very well, because 9 times 7 is 63. That'll take me a long time to get back to 7 from here. So I'm not going to try 8 and 7 this time. I'm going to try some of the bigger numbers now that I have 9 as a big number. So I could try something like 14 and 4. Now, I don't want to put 14 here because I have to do 9 times 14. I'll try 4 here with a 14. 9 times negative 4 is negative 36, plus 14 here is going to be still too large. Negative 22. So it looks like that one doesn't work there. So, I already know with the way that I'm testing these here. Let me try 28 and 2. So 28 here and 2 here. Again, reason I'm not trying 28 here is because that'd be 9 times 28. Huge. 9 times negative 2 is negative 18, plus 28 right here. That is 10. That doesn't seem to work. I need to make sure that I didn't, miss or mess up an answer here. Did I try 56 and 1? Maybe this one's not factorable when I play with this. Let me pause this for a second, see if I can determine the factorization on my own here. Okay, so what I decided to do was just look at the answer key because I started to question whether this was factorable. Let's go down, number 16, not factorable. So once you start playing with all the different factors, you might realize when things are factorable or not. Looks like a few of these are not factorable. But anyway, look, some might not be factorable. And I think that's another important message to state here. That, every so often you try all your numbers, you figure out it's not factorable, and then you stop. It's prime. So, yeah, after spending just 20 seconds going like, I just think it's not factorable, I just checked and saw there was a key and it's not. But if it was factorable, and that's the point, that the reason why I'm drawing the factor things right here is I say, if it is factorable, then I know it will look like this and either 3 and 3 or 9x and 1x and whatever else. And I also know it would be a plus and a minus. In this case, I guess it just wasn't. But anyway, I think that's enough for me spending time with that one there because I hope I answered the question early on when it came to the other things there. That's why these power hour videos sometimes don't really work very well. But yeah, I hope that answered it when it comes to the signs. You know that it's plus and minus with a negative product. You only have to switch the signs if you find the opposite version of it some. And you know it's going to be with a positive product, it's either positive and positive if your sum is positive, or minus minus if your sum is negative. All right, so I'm going to go ahead and move down, guys. So that was my IM2 Sol question there. Let's go down to Integrated Math 1. Let's start looking at some of these questions here. The first question that is asked is, can an undefined slope go on for infinite number of units? Can it go on forever? Yeah, all of your lines do. So you asked slope. Slope is calculated by some rise over some amount of run. Undefined slopes have no amount of run, so it's an infinite up and down on y. Yeah, they go up and down forever. But all your lines do. Even if I have a slope of up 5 over 2, that's just the rate for that one point. It still continues forever on that line. Sometimes if you restrict your domain to something, I'd understand if you'd say, hey, we're going to eat 5 slices every 2 minutes for a total of the next 20 minutes. And then your domain is limited from 0 to 20 and stuff. So I guess that's not infinite. But the lines that we draw with the arrows on them means they go up and down forever, left and right forever, things like that. So undefined slope goes on infinite units. Yeah, totally. Yeah, I don't really know what else to say to that. Okay, with that question down, let's go to the next one. I don't know why you wrote a 1 here. Oh, 1 and 2. Okay, number 1. Can you turn a 0 solution into a 1 solution? 2. Can an undefined slope become negative, or will it always be undefined? Let me answer number 2 first, because I'm not sure if number 1 is answerable with the context of what we've talked about. The answer to that's kind of no. Okay, the answer to these are kind of no. I want to know that you know what a 0 solution actually means, because we haven't run into no solutions together ourselves yet. Okay. I'm going to answer number 2 first. Can an undefined slope become negative, or will it always be undefined? Let me draw a vertical line, because undefined slope's a vertical line. So let me draw one out. I even have a graph stuff. Let me pull this in. So I have a graph thing here. Let me draw you a vertical line. Now, you don't know the equation of these things yet, y equals mx plus b form, because it is not in y equals mx plus b form, because there's no slope. Okay, so say you have a vertical line at x equals 3 right there. That's actually the equation of the line. The equation is x equals 3. Anyway, let's say you have that. So you're trying to determine the slope, right? And you say, oh, I know this point and I know this point. Let's just say you knew those 2 points there. 0, negative 3 and 0, 5. So we're talking about, hey, what's the rise and run? Well, it rises 8 and it doesn't run at all. So your slope is 8 over 0 and we decide that's undefined. Okay. Same thing with what if I went from 5 to negative 3? Well, then it falls 8. So you might say your slope is negative 8 over 0, and maybe your question to me is this negative undefined? I guess that may be what you're asking me. No, there's no negative or positive undefined. The fact that we rose or fell actually means nothing because it's with respect to 0 run. It doesn't matter. As long as it changes some y and no x, it's just called undefined. Not positive undefined, just undefined. Division by 0 is undefined. 0 divided by 0 is called an indeterminate. Now, I don't know if that question's asked. What's the difference between 0 divided by 0 and non-zero divided by 0? The similarity is they both don't have a value, a known value. The other question was, can you turn a 0 solution into a 1 solution? So I don't know if you know what it means to have a no solution case, whether it's graph or equation. On a graph, so the solutions on a graph, and we're not in this section yet. We're going to get in this next unit, so I don't know if this really matters yet. But in a system of equations thing, a solution means the point of intersection of like two equations like that. What is the x, y? That would be a solution. A no solution case would be if your lines don't intersect. Well, how would your lines not intersect? One way is if they're parallel, like that. That's really the main way. If they're parallel, they'll never intersect. That means no solution. And so I don't know what you mean by can you turn a no solution into one solution. If your system is a no solution system, then that's what it is. If you want me to change numbers, then I'm changing my system. So, I mean, I'd change it, but now I'm fabricating something. It's like, well, x equals 7, but let's just make x equal 4. Let's just do that. You can't just do that. So yeah, I don't really know what to answer with that, and because unless you didn't really mean the word solution, I don't know what you mean then otherwise. Same thing with slope. Can I turn a 0 slope into a 1 slope? Not for an equation where it's having me calculate slope. I need to use what they give me. So yeah, I don't really know what you specifically meant by that question. I hope I was able to answer it to my fullest. All right, next question. Why must we learn the many types of ways to write an equation for a linear line and learn, that's a good question, and learn how to solve it when we could simply use one? In other words, why do we learn the many forms and what would they be used for? Michael Vick. Thank you, Michael. So, Michael, to answer your question here, because the very last thing that you asked is kind of the answer to the question, because some are used for other like some have more like better benefits than others. If I could pull it up, I won't pull it up. Well, I can pull it up in my video. I'm going to pull up in a video a diagram that I made that you guys have seen the video for as well, or I posted the video for you guys as well. It's a splash screen. I call it a splash screen that has all these different nooks and crannies of linear equations. So it's right. I'm going to find it right here. Linear functions. Is this it? That one's not it. It's the one right after. I'm sorry. Give me 1 second here. It is this one right here. Yeah. So in this video, it's one of the videos on this channel. It's called Forms of Linear Equations. In this video, I have the splash screen right here. And in the splash screen, it shows standard form. That's a form of linear equations. Point-slope form and slope-intercept form. Note that an equation can be linear and not be exactly written in one of these three forms. But each of these three forms have benefits, either when it comes to graphing, word problems, things like that. They actually represent some things within here. We haven't talked deep into standard form, but it is best used. Here it is best used when solving for intercepts, your x and y intercept. The y-intercept set x equal to 0. The x-intercept set y equal to 0. And it's setting up some word problems. We're going to be looking at some word problems that are expressed in standard form. So understanding the concept of standard form is pretty good. And your book defines the standard form of an equation. If it's written in this form, then you know that it's linear. There's that as well. Slope-intercept form is most people's preferred. It looks cleanest. They say it a lot. Y equals mx plus b. You graph out of it a lot. So it's most people's preferred. It is best used for graphing and setting up functions. If you have function notation, f of x equals, heck, our arithmetic sequences, f of n equals, and we get in 7n minus 2 and stuff like that, that's kind of slope-intercept form-esque. Let me move my phone away to the side here. So slope-intercept form, a lot of people love. They understand starting on the y-intercept. Pretty clean looking, good to go. The question comes because you learned point-slope form. And point-slope form is busy looking. It has subscripts, parentheses. Stuff is on the same side with y together, stuff like that. It's where m is slope and x1, y1 is a known point. Best used when given 2 points or a point and the slope, because you can just substitute things in then and there. Or you can take that information and then put it into a graph and graph right from that point. This is also best used, and you wouldn't know this from the jump, but it's also best used when you have a y-intercept that's a fraction. So because your question is probably, why are we learning this form when we have this form? I could graph easily from this. I could make equations easily from this. Have you graphed with a fraction y-intercept before? Because that's not fun. It's not fun for me. It won't be fun for you. When you have a fraction y-intercept, but it passes through some integer x1, y1, you'll have much more of a ball with it. And I know for sure, and I got to find out exactly where the timestamp is to show you, but there is, I'll probably put it in the description section with your question and give you a better version of the answer. In that long video that I made earlier today using some IXL solution guide stuff, I find a problem that starts off in point slope form, and I say, here's why graphing out a point slope form would have been better. Because if I convert it in slope intercept form, I'd get a y-intercept fraction, which means I have to find common denominators, and which means I have to start from my fraction y-intercept to work, instead of just starting from that one point and going there. And that's why. I mean, it makes it a lot easier if you just start from that point. Point slope form, if you're in calculus, you like to just leave it in this form, finding the equation of a tangent line, stuff like that. It's something that's very graphable and has its uses. It's more distracting, it's a little more confusing looking, but it has its uses. Standard form is pretty nice. You never have fractions with standard form. It always starts with a leading term that's positive in standard form. So standard form has its nice uses there as well. And you write some word problems setting it up that way. So it's just nice to just understand that there are pros and cons to each, and when you understand the pros and cons, then you'll know which one you want to choose. So we give you that familiarity. And believe it or not, some people prefer point slope form. So maybe to some of the people who I presented it to, they're like, I kind of like point slope form more. I know most people don't, but some actually do. All right, Michael, I hope that did answer your question. Thank you for asking me about it. Let's move down to the next question here. And the next question says, when given 2 points and you have to find the slope, why does the y have to be above the x? Well, it's not just about when given 2 points. Your real question here is actually, why is slope change in y over change in x? I think that's the overall question. Why is the slope the change in y over the change in x? So, yeah, slope equals rise over run, change in y over change in x. Why do they do it that way? Now, I don't know if you're asking, why do we always have to do this way and we can never do it the other way? The answer to that is to stay consistent. That way, if I have a 2/3 slope, I know whether I'm talking about rise versus run on 2 and rise versus run on 3. In this case, the rise is 2 and the run is 3. We're being consistent. Why did they decide to do it this way as opposed to change in x over change in y? Because, I think many people are like, when we plot points, if I plot the point 2, 3, I know that I go 2 right and 3 up. But now when I have a slope of 2/3, now you're making me go 2 up and 3 right? Why are we doing that first instead? Maybe that's where the question comes into play. The best answer I can give, and I'll kind of give a second one, but the best answer I can give is they wanted to make it so that the larger the value, the steeper the slope. The larger the value, the steeper the slope. And a slope of 0 means flat ground. Okay. It's also a way of being able to go to negative slopes the other way. So think about what I'm talking about there. When I have a slope that has rise of 0 and a run like this, that's a terrible, hang on, let me do that again. Let me actually pull in the graph. If I have a slope, sorry, I'm going to ignore all that. Well, I'll just be playing with this, just finagling around with it. Here's a positive slope. This is, let's say, going up 1 over 2, up 1 over 2, up 1 over 2. When I raise this to a slope of up 2 over 1, see, a slope of 2 versus a slope of 1 is steeper. A slope of 2 is steeper than a slope of 1. A slope of whatever this is, probably close to 10, I'd say that's 8. A slope of 8 is steeper than a slope of 2. So the higher the number, the steeper the slope. Therefore, the lower the number, the less steep the slope, and lower, 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 until you get a slope of, say, 1/8, something like that, close to 1/8, and until it gets closer and closer to 0. You can get a 0 slope, and 0 slope is flat, and then past 0 are the negative slopes. So it's, kind of just like a number line. Get closer to 0 until you hit negatives. So like that. So that's kind of a nice way to do it. Otherwise, if you have run over rise like that, then this would be an undefined slope. And then you go to negative. But that would kind of sound weird to us. We want an undefined slope to be the vertical one, because that kind of ties in with the whole it's not a function kind of play. And 0 slope is like 0 degrees, so flat ground. So I think that's just my best answer for you, is that it wanted to find a way to account for the 0 slope here, and then to go to negative slopes thereafter, and the larger the number, the steeper the slope. That's the best way I can talk about it. The other context I can provide is when we talk about word problems and we talk about time, and as time goes on, what's occurring. This doesn't just have to be me drawing the graph, but slopes can be represented as their fraction form. So I can talk about something like, hey, when you're driving and you go 60 miles per hour, what that really means is you've traveled 60 miles in 1 hour. That per is actually a division. 60 miles per every 1 hour. And x here is your time, right? X is represented as time, and y can be represented as distance or amount of work done or something like that. So once again, as this happens, how much do we rise or fall is just kind of the talk there. So there's good relevance to it. I would never want it the other way, not just out of familiarity, out of logic. I would never want it the other way. I like it this way. I think you had a great question asked, and I hope that did answer it. All right, with that being said, though, I'm going to move on to the next question here. And the next question that's asked is, with the y equals, where'd it go? With the y equals mx plus b, do you just fill in the numbers you get from your equation? Your numbers are in your equation, unless you mean from your line. If you say with the y equals mx plus b, do you fill in the numbers you get from your line? I don't know if that's what you mean. Let me answer it both ways. I don't know if you're talking about getting... I don't know if you're talking about a graph, if you're talking about information. So let's play some things out right here, shall we? Let's go here. Let's look at y equals mx plus b. Y equals mx plus b gives you the slope in the y-intercept, of course, right? So if you're talking about with a graph, if you're talking about from your line, because I don't know if that's what you mean, I still try to ask students to be more specific, and I'm not hating on you for that. I'm just saying just try and be more specific. That way I make sure I have a focused answer here. So let's say I have this line right here. Not perfectly put, but let's say we know this point and we know this point right here. So that is a y-intercept of 1, positive 1. So when I know my y-intercept is 1, I'm going to put it in there. And when I have a slope, I'm rising 3 and running 4 right here. Then I know my slope is 3/4. So I'm putting my numbers in. Excuse me. What was the question? Fill in the numbers you get from your line. Yeah, if I get these numbers from my line, or if you're even talking about 0, 1 and 4, 4 right there, that'll get to the next question I'm going to take. You could also calculate some things there. So let's say you didn't have the graph, and let's say I only had that information. And in that information, I know I have the points 0, 1 and 4, 4 right here. Actually, let's say the 0, 1, and let's say a slope of 3/4 right here, because this is what we started from. Maybe this is when you first asked the question when we were doing these. Slope of 3/4 and a point 4, 4. We have to write it in slope-intercept form. So my y equals mx plus b means that I don't yet know my b, but I know it's going to be 1. But I know my slope is 3/4 here, and I have an xy that's 4 and 4. So 4 for y, 3/4 for m, 4 for x, yeah, you just plug them into there, you find b, and then you plug in that b into your equation with your m. 3/4 of 4 is 3, 3 plus b is 4, so b is 1, therefore our equation is y equals 3/4 x plus 1, same y-intercept as before. So again, I don't know which way you're kind of asking this question here. The last bit is maybe if you have your slope-intercept form, you pull out the information, these numbers, and you use that to make your line. Slope is 3/4, y-intercept is at 0, 1. Use those and get it. So again, I don't know what you're asking there. Do you just fill in the numbers you get from your equation? This is the equation. So if you're talking about pulling out the numbers here in order to graph it, sure. Yeah. If you're talking about getting information like this and plugging it into here, sure. Yeah. I mean, you got to find a b value in order for it to work. I could have used point-slope form here as well and converted it to slope-intercept form. If you had 2 points, you also got to find the slope. So if this was 0, 1, 0, 1. Maybe you have to do your y2 minus y1 over x2 minus x1, and you get your 3/4 before you plug in one of these two into the equation, and then doing that as well. So a lot of different things to that. I don't know which way you're asking it, but you are going to substitute based on information that you see on a graph, or you can pull from your information and then plug them in to be able to get the information you need. You need m and b. You need slope and y-intercept for slope-intercept form, or you need to pull out the slope and the y-intercept from that form in order to graph it, say. So I hope that answered that because I tried to cover a bunch of different things from there. All right, next question is, how do you subtract things to get it into standard form? Okay, we're not doing things in standard form currently right now. If you're talking about getting out of standard form, I will tell you, and I'll link for you in the description section as well, where I do that video thing where every so often I get some standard form questions and I'm converting into slope-intercept form. If you are actually talking about converting into standard form, though, you haven't really been told a lot about standard form yet. I just told you a little bit more in the Power Hour video today. Standard form is a kind of a tricky nugget, because in standard form, they really do want, and I know other books will say different things, but my basis of standard form is all of A, B, and C are integers. They're all integers, even if they're 0. They're integers. A and B both can't be 0 at the same time. But all of A, B, and C are integers, and A has to be positive. So say you have slope-intercept form. Let's say we have y equals negative 3/7 x plus 2. And you say convert it in standard form. You say, how do you subtract things to get into standard form? The goal is to get x and y in the same side of the equation. And another mini goal within here, of course, is to get all integers. So this is dividing by 7. So what I would do here is I would multiply both sides by 7. And again, I'm doing something unlike what you're going to be asked to do. I multiply both sides by 7, and 7 distributes here. I have 7y equals 7 times negative 3/7 x is negative 3x. The 7's kind of go away. And 7 times 2 is 14. And now I add this x term over. I add 3x to both sides here. And then I'll get 3x plus 7y equals 14. That's my standard form here. Now, standard form doesn't have its graphing uses the same way that it does in slope-intercept form. If you already have slope-intercept form, you should probably use that. Standard form might have its uses to put in here, especially when it comes to using elimination method for systems of equations. We haven't done that yet. When it comes to, like, I don't know, there are a bunch of different things there. Maybe finding your intercepts here might be easier. X-intercept, I don't know. It looks nicer, but my slope isn't 3. My y-intercept isn't 14. My slope was negative 3/7. My y-intercept was 2. So I don't know. I'm not converting in standard form with you guys like right now, so I'm not going to talk about that. If you meant go from standard form to slope-intercept form, we've done a lot of that. I do want to point you to my video that I gave you, but I will use this equation again right now and show you what that looks like. So let's say I have 3x plus 7y equals 14 from the jump, and I need to get it back into that equation that you saw. So 3x plus 7y equals 14. Your goal is to get y by itself. For slope-intercept form, it needs to be y equals mx plus b. So I start by subtracting 3x from both sides here. And then I'll get 7y equals negative 3x plus 14, as those don't combine, and you want the x term first for y equals mx plus b. And then when you divide 7, you divide everything by 7 right there. Now, there's also a point-slope form to slope-intercept form as well. That one's also in the same markers in that video that I talked about. Every so often, I don't show the work because I did it a bunch of times in that video. It's the IXL thing where you convert and you solve for y. It's getting in slope-intercept form. That video covers a lot of them. So if that's what you're asking, great. If you're talking about standard form, you want to get it into this form, x and y in the same side of the equation, where a, b, and c are all integers, and hopefully a is positive. That's the best look of standard form that one can provide for somebody. All right, this Power Hour might actually end up being an hour, so let's just keep on moseying along here. I have how many questions left? 4 questions left. How do you find the slope through an equation? Well, it depends on the form that you're in. Well, I don't know if you're talking about an actual equation or if you're talking about an actual line, right? Because some people, I think that last question that said equation, I think they might have meant line, so I don't know. If you're talking about an actual equation, it depends on the form that you have. So there are 3 different forms which we talk. There are really 2 forms we're talking about. Standard form is actually, honestly, often not one of them. I'll leave it here, though. There's slope-intercept form, and there's point-slope form. These 3 can somehow reveal something about your graphs. Standard form takes very quick calculations, but it's there. The slope in slope-intercept form and point-slope form is m. That's your slope. In standard form, the slope is not immediately realized, meaning A, B, or C are not your slopes. If you really want to know what it is using letters A, B, and C if possible, I'd have to put it into slope-intercept form. And I don't mean with an actual example, I mean with these actual numbers here. If you want to know what the slope is out of standard form, subtract AX from both sides. I know you're not going to like this. Subtract AX from both sides, and I get BY equals negative AX plus C. Whoops. Plus C. And then if I divide by B from both sides here, I'm going to get y equals negative A over BX plus C over B. So your slope-intercept form from something in standard form is, your slope is this m, the negative A over B. So your slope from, hang on, m equals negative A over B. Your slope, if you're in standard form, you can take the B, take the opposite of B, and divide it by A. That sounds weird. I didn't even know that. Like off the top of my head, it's like, hey, what is it? 3, 2, 1, tell me. I didn't know. I'd have to work it out. You could graph from it instead, find the intercepts, and then maybe that can help you find slope through certain points. But yeah, I don't know if you asked for an equation, through an equation actually. If you meant from a graph, or if you meant from 2 points, you know, those are different things. There's a slope formula. Maybe you're asking about, what about the slope formula? The slope formula is y2 minus y1 over x2 minus x1. What do those have to do with? That has to do with if you have some sort of graph, and I'll make a very generic graph here. If you have some sort of graph and you have some point right here that's x1 comma y1 and some point here that's x2 comma y2, you can find the slope between those 2 points like that. You don't have to be given the graph to calculate these, but you have to be given the points or given the graph so you can determine your points that you're trying to find. Right? Sometimes they don't actually give you the points. You have to see where they cross through to tell yourself that. So I subtract y2 minus y1 and I do x2 minus x1. I get a slope there. If you're talking about finding the slope between your lines, same kind of things I said before. You can either pull out your numbers and calculate the slope here, or you can count how much you're rising and running from one y to another and from one x to another. How much from here to here, count it or subtract it, and from one x to another here, count it or subtract it. Hope I answered the question among those different things there, because I can't, sometimes I can't tell, and I'm not blaming you, but I'm blaming you, if you know what I mean. Like, I can't for sure know what you're asking unless I really, really see all the words as they're supposed to be in the question there. But I hope that answered your question. Can infinity be divided by itself? I'm wondering where people are asking about infinity. I don't think we've been really talking about infinity yet before. Can it be divided by itself? You mean and get a number? No. It's a good question. It's something more, save it for pre-calculus or something like that. I talked about 0 divided by 0 being an indeterminate. Infinity divided by infinity is also an indeterminate. We know that any x divided by x equals 1, provided that x is not 0. Because, right, if I divide by 0, it's a problem. Even 0 divided by 0 is a problem. Any x number divided by itself is 1. Does that mean I could plug in infinity for x and infinity divided by infinity is 1? Not quite. Because infinity is not a number. Infinity is a concept of endless bound. There are different sizes to infinity. And people are like, what do you mean there are different sizes to infinity? Well, I mean, if you take infinity and add 1 to it, if you treat infinity like a number and you add 1 to it, you get infinity. So are we saying that this infinity is equal, are we saying that this infinity is equal to this infinity? No, they're different sizes. Take the largest number in the world, which there isn't one, but if, say, you had the largest number in the world, I could add 1 to it, or I could double it, or I could raise it to the 100th power. Just, there's no largest number. That's what infinity is, the concept of a limit as we approach something, as we approach an endless bound, the endless limit. So there are different sizes to infinity. That's the main reason why we can't divide and just say that it's 1. Now, I do know that if I divide negative infinity by positive infinity, I'm approaching 1 there, and here I'd be approaching negative 1. It doesn't equal it, though. It's an actual indeterminate in that. Here's another concept for the idea behind sizes of infinity being different. If I asked you guys how many numbers are between the values 0 and 1, like how many numbers? You'd say there's an infinite number of values, right? There's Like, right, take half of 1, take half of a half, take half of a quarter, take half of an eighth. You keep taking halves, you're going to get small numbers, and you can go by an infinite number of increments. There's an infinite amount of numbers between 0 and 1. Well, there's also an infinite amount of numbers between 0 and 2. Does that mean that there are more numbers? Excuse me, does that mean that those infinities are the same size? No, because technically there are more numbers here than there are here, but infinity in itself is already a concept. I don't know why I'm going on about this. Infinity in itself is already a concept that speaks to the idea that, well, it's an endless bound that you can't reach. There's an infinite set within, and there are different sizes of infinity. One can be more than the other. Anyway, so I hope that answered your question. No, you can't divide infinity by itself, but you can determine possibly what value it would approach, not what it would exactly equal. Because if I do super massive million billion number divided by super massive million billion number and 1, that's getting really close to the number 1, but it's not quite the number 1. Although those could both be concepts of infinity getting really large. Excuse me. When finding the equation of a line in point-slope form, how do you find both the slope and the xy axis using just one point? Aaron Mason. Okay. How do you find both the slope and the xy axis? Do you mean the intercepts? Do you mean when finding the equation of a line? Okay, I don't know if xy axis is what you actually mean, because the axes are the things here. Hang on. How do you find both the slope? So you might actually be talking about, if you're in my third period, I think you're in my third, you might actually be talking about the IXL activities that we did. And in the IXL, here, let me pull up IXL and show you that. Give me a moment. I actually have to log in. I'll find the thing we were doing. You might be talking about the thing where they give you that big red dot. Oh, I am logged in. You might be talking about the thing where you got to find that big red dot, or where they give you that big red dot, right? Like write an equation from a graph. You talking about this? I hope you're talking about this. So you're asking, hey, they give us a single point. I need to do point-slope form, but in order to find the slope, I need to know another point. So how can I do what I got to do here? I hope this is your question here. All right. Hope this is your question. So, let me go back to Excel. Or IXL. So right here, that known point right there is 10, 9. I know a point on my graph that's 10, 9, but I don't know my slope through that point because I need to know another point on top of it. Because if I don't, I can't find my slope. Because how many different points go through 10, 9? Or how many lines go through it? This line does, this line does, this line does, this line does, this line does. All those have different slopes, right? So for 10, 9, I need to know another point there. So you got to kind of trace it. You got to kind of look through and say, where's another time where I land on some other point here? I mean, I land on a point right here. I land on a point right here. Heck, I land on a point right here, right next to it, right? So depends on the points you have. Let's say you weren't using the graph and you were using numbers. Let's say I chose one way down here, like 3, -5. 3, -5 is another known point on this graph here. Well, you find your slope by rise and run. How much do I run from 3 to 10? I do 10 minus 3. How much do I rise from -5 to 9? I do 9 minus -5. 9 minus -5 is 9 plus 5. That's 14. 10 minus 3 is 7. 14 over 7 is 2. My slope there is 2. So I can calculate it. I can use this thing to count it. I could have just... From here, I could have gone up 2 over 1, and that would have been it. So you got to use another point. I know they only marked one. I think it's because IXL only knew one way to answer this question, and in point-slope form, you actually use the point for it. So they wanted you to definitely use this number in the form. But they're saying, on your own, you got to identify what this is, and you got to find another point for yourself. I hope I'm answering the question that you're asking here. Now, that was my slope. In point-slope form, you can choose any xy value to plug in for x1 and y1 that exists on the graph. I won't just have to choose 10 for x, 9 for y. On this assignment, I'd have to plug in 10 for x and 9 for y. But I also could have substituted in, here, let's start 10 for x and 9 for y. Let me copy and paste this thing. So for point-slope form, when I'm trying to write the equation, I could have substituted 10 for x and 9 for y. Or I could have even substituted 3 for x and negative 5 for y. Now for negative 5, that means you add it. Minus a negative, right? Either of these, both are the exact same line. They make the exact same line. You just start at a different reference point and you climb to run 1, rise to run 1. You keep going there. But yeah, you got to find another point within it. I know they kind of give you one of them. You still have to find another. If all they gave you was the slope and the point, well, you could just write the equation right from there. You don't have to do anything. If you wanted to find another point on the graph, you'd have to draw the graph and then figure out where it lands. So anyway, I hope that answers that, because that's just a lot of different ways I'm looking at that. All right, let's see. The final question here asks, sports a, maybe this is a title, sports. A figure skating school offers introductory lessons at $25 per session. So you're giving me a specific question here. You know you don't get credit for this, right? There is also a registration fee of $30. Write a linear equation in slope-intercept form that represents the situation. You want to take at least 6 lessons. Can you pay for those lessons using a $200 gift certificate? If so, how much money? If any will be left on the gift certificate. If no, explain why not. Now, we will be doing questions like this, I think, coming to the beginning next week, but you can't just ask me a question for me. I'll solve it. I'm just saying you can't get credit for that as a student when it comes to asking questions. Still ask me another question at least that's more general. Look at the other questions that were asked above for our content. So here we go. Figure skating school offers introductory lessons at $25 per session. So that's kind of your rate, $25 for every session. So if I'm going to do, this kind of is going to be a y equals mx plus b thing. So my m in this case is 25, talking about $25 per session. There's also a registration fee of, I think that says 30, of $30. That means that's kind of my y-intercept there. That means if I don't take any sessions and I sign up, I'm still paying the $30. And the 30 doesn't change no matter how many sessions I take. It's still a 30. So my equation is going to be y equals 25x plus 30. Now, my x and y are kind of important to note here what they mean. $25 per session times the number of sessions here. X is number of sessions. Y is total amount paid, total cost. After X sessions, if you have 10 sessions, whatever. Actually, they say how many sessions here? 6? You want to take at least 6 sessions. So let's see what happens if I take 6 sessions based on this equation here. If I take 6 sessions, I'm going to substitute 6 for X. So I'll say, how much do I pay if I take 6 sessions? Plus $30 here. That'll be $150 plus 30, which is $180. I'd be spending $180 on 6 sessions here. It says at least 6, so I wonder if that has to do with an inequality here. 6 sessions. Can you pay for those lessons using a $200 gift certificate? Yes, for 6. It says at least 6, though, which is kind of weird, because if I do 10 sessions, I'm going to go over my amount. But if it's 6, let's just say 6. If it's 6, I've only paid $180. I have a $200 gift certificate. I have $20 left on the certificate, because I have more on my gift certificate than I'm actually paying for. So if so, how much money will be left on the certificate? $20. If not, explain why not. Well, there it is. So there it is. Okay, I answered your question. There it is. All right, so that'll do it for the Power Hour, guys. I did finish it in less than an hour. I thought it would be a lot less than an hour, but as you know, I tend to talk. I hope you enjoyed this one here. Take care, guys.